Hello, everybody. We have a new lesson today. Section 1.3, properties of numbers. And I'm going to tell you right now as we go through this lesson that you might be thinking in your mind like, duh, this is obvious stuff. These properties are things you have learned before. You may or may not know or remember the names of them, but being able to understand it and recognize it is going to be really helpful throughout our year this year with algebra when we move into a lot more things with variables. So again, as we go through it, you might be thinking, well, this is easy. And primarily it is. We'll get to a few tough spots, but don't be alarmed if you feel that way. So we're going to start with the identity and equality properties. And these, again, shouldn't be anything new. So for example, the additive identity. 0 is considered the additive identity because when we add anything to 0, we get that original number back. So I always like to think of it as when I add myself to 0, I get to keep my identity because I get myself back. So for example, we would have 5 plus 0. 5 gets to keep his identity. He's still 5. Okay, the next one is the additive inverse. And you might think of this one as adding opposites. And that when we add opposites or add inverses, we get 0. So for example, 5 plus negative 5 is 0. The third one, don't laugh, but I love to say the word multiplicative. I don't know why, but it is a fun word to say. So multiplicative, if you're not somewhere where you'll be embarrassed saying that out loud, say it out loud to yourself. Multiplicative. It's just a fun word to say. But the multiplicative identity, again, you get to keep your identity. So the multiplicative identity is 1. So for example, 5 times 1, we get to keep our identity, and it's 5. And then we have the multiplicative property of 0, which just tells us that anytime we multiply something by 0, the answer is 0. Easy enough. And the next one is the multiplicative inverse property. And you might think of, you've probably learned the word reciprocals. This is the same thing. So the multiplicative inverse is the same as a reciprocal. And so this just says that if you multiply two inverses or multiply their reciprocals, then you get 1. So for example, if we have 3/4 times 4/3, notice that those are reciprocals. It's the same numbers, just flipped upside down. That equals, remember, when we multiply fractions, 3 times 4, we do numerator times numerator, we would get 12. Then we do denominator times denominator, and we would get 12. And then, of course, we know that 12 divided by 12 is 1. And so when you multiply inverses or reciprocals, the product is 1. Now, this next group of properties are a little strange, I'll be honest. Maybe later on in high school you will use these a lot more, but they're just kind of strange to me. And I guess they're strange to me because they seem so obvious, even more so than the ones we just did above. So the reflexive property simply states that any quantity is equal to itself. Well, duh. I would hope that we know that, but maybe I'm just thinking about it too much. But an example of it is that 5 equals 5. That's the reflexive property. Now, one way that I remember the reflexive property is the word reflexive makes me think of the word reflective. I know that's not mathematical, but so I think of when 5 looks in the mirror, he sees 5, and that's it. Okay, so it's reflective of each other. They're the same on both sides. Then the symmetric property says that if one quantity is equal to another, then that second quality is equal to the first. Again, seems pretty obvious to me. So for example, if 5 equals 2 plus 3, then 2 plus 3 equals 5. Okay, pretty obvious. When you see the phrase if then, that usually is telling us that it's symmetric. So the whole if then thing is usually implying the symmetric property. The transitive property is similar, only this time it involves 3. We're going to have if and then. So it says if A equals B and B equals C, then A must equal C. So here's an example. If 6 plus 9 equals 3 plus 12 and 3 plus 12 equals 15, then 6 plus 9 must also equal 15. So the transitive property always has that 3-component thing. We have if, and, then. All right, so those are those 3 properties. And then the final one we're going to talk about right here in this chart is the substitution property. And the substitution property also seems very obvious, that if A equals B, then A can be replaced by B in any expression. So for example, if 5 minus 3 is 2, then that means that if I have 6 times 5 minus 3, I can replace that 5 minus 3 with 2. And that's called substitution. I'm substituting the 2 in for the 5 minus 3. Okay, so the substitution property we actually use a lot. That's really how we simplify things, is we substitute an equivalent value for another value. And then the last 2 properties we're going to talk about, I know you've learned a ton about, and that's the commutative and associative properties. And the commutative property, remember, is when we can change the order in which we add or multiply numbers, and it won't affect their sum or product. Whereas the associative property is when we change the grouping of numbers when we add or multiply, and it doesn't change their sum or product. But we have to remember that this only applies to sums and products, not subtractions and not divisions. So for example, with the commutative property, with addition, we could have, 3 plus 5 is the same as 5 plus 3. If we're multiplying, we could say 3 times 5 is the same as 5 times 3. And then with the associative property, same basic concept. If we have 3 plus 5 grouped together, and then we add 7, that would be the same as taking 3 and adding that to the group of 5 plus 7. We'll get the same answer either way. And same thing with multiplication. If we have the product of 2 and 6 multiplied by 9, that would be the same as 2 being multiplied by the product of 6 and 9. You're going to get the same answer either way. So that hopefully is just a review of those 2 properties. Okay, turn the page over, and we're going to look at kind of combining the lesson we did yesterday with order of operations and lesson today about naming the properties that we use to justify our steps of order of operations. Now, in real life, as we move forward, when we are just simplifying a mathematical expression like that, we won't always be stopping and doing one step at a time and naming each property. But it's important for us right now to understand exactly why we're allowed to do each step. And these properties are the rules that mathematics are based on. And so it tells us that it's okay to do each step. When you get into geometry next year, you're going to do what we call proofs, and you'll be doing a lot of this type of thing. So this is just helping you get ready for that. So here's our original problem. Just like yesterday with order of ops, we're going to do one step at a time. So you'll notice that 9 divided by 3 is 3. And so that's substitution. 9 divided by 3 is 3. I'm going to run out of time on this video, so I'm going to stop it here and add a part 2. I apologize for that, but pick up part 2 here in 1 second.